Welcome to our notes on equations, graphs, and tables. Students will be able to create a table of values by plugging inputs into functions and translating the inputs and outputs to coordinate points to graph. Students will be able to verbally explain how to graph a function from an equation. So let's take a look at the quadratic function, f of x equals x squared. Okay, so we're going to evaluate this quadratic function at all of these x values in this table. To do that, what I'm going to do is I'm going to go ahead and add that in. So this is what I call like a function skeleton, in which I replace the input with a set of blank parentheses. And now what I'm going to do is I'm going to plug in 0, because that's my input for this line. Now what does the 0 squared mean? It means I'm going to take 0 and multiply it by 0. And 0 times 0 is 0. Okay, so for the ordered pair, my input was 0 and my output was also 0. Okay, so let's look at another one and do that. So I'm going to write the function skeleton again. And this time I'm going to put in x equals 1. Well, 1 squared means 1 times 1, which is 1. So I know this doesn't seem very, thrilling, but let's try the next one. F of blank equals blank squared. I'm going to put 2 in there. Okay, so this means 2 times 2 is 4. Okay, my input was 2, my output was 4. Let's try f of 3. Okay, I just wrote it straight through this time. 3 times 3 is 9. So my input was 3, my output was 9. Are you seeing what we're doing here? So f of 4 is 4 times 4, which is 16. Input was 4, output was 16. All right, so I want you to finish the rest of this table. Okay, so let's look at the square root function. G of x equals the square root of x. Okay, that was this one right here. So g of x equals the square root of x. And we're going to have all of these inputs. We're going to evaluate them. So once you created your table for the quadratic function, this should be a little bit easier. So let's go ahead and work on that now. So g of blank equals the square root of blank. So what am I going to put inside of those parentheses? I'm going to put 0 in here. Now, I can go over here and say, hey, what squared gives me 0? What squared gives me this? Well, in order to get this, I had to square 0, so that is my answer. Okay, so 0, 0. All right, it's a little anticlimactic for the first few, but that's okay. We're going to do a few more. Okay, parentheses. So I'm going to put a 1 here and a 1 there. What squared gave me 1? Well, I ended up squaring 1, so this is my answer for this one. Okay, I know doesn't seem very different. Now let's look at this one. G of 4. Okay, I'm going to put 4 here. And honestly, those parentheses are a little unnecessary in this case, but that's okay. So I'm asking myself, what number did I have to square to get what's under the square root? So I got 4 by squaring 2. So 2 is my answer. Right? Do you see this pattern? Let's do 2 more. G of blank equals the square root of blank. Remember, those parentheses are there, but they're invisible because we don't need them in this case. But if you want to be on the safe side, you can go ahead and put them in. All right, so I'm going to put 9 inside, and I have to ask myself, what number did I have to square to get 9? So I got 9 by squaring 3, so 3 is my answer. Do you see this? Okay, G of 16 equals the square root of 16. I just went ahead and put that in there. What number did I have to square to get 16? Okay, so I got 16 here, by squaring 4. So it's working backwards, right? Notice that the outputs here were the inputs here. The outputs here are the inputs here. Okay? So they are actually functions that undo the other. So let me just go ahead and write the ordered pairs here. Our input was 4, our output was 2. Our input was 9, our output was 3. Our input was 16, our output was 4. So notice that these points switch their x and y's. Okay? And you'll learn more about what these functions are called relative to each other later. I should also say go ahead and finish this table for the square root function. All right, so it says try evaluating the following. So we have some negative inputs now, and I just want to remind you that f of x, actually I use blue, so let me go ahead and use blue. F of x is equal to x squared. Okay, so again, what I'm going to do is I'm going to write this squared, and I'm going to put negative 1 in here. What does that mean? That means do negative 1 times negative 1. Well, what happens when you multiply two negatives? You get a positive 1. You don't have to write the little plus if you don't want to, but I was just emphasizing that a negative times a negative is a positive. All right, let's do that for f of negative 2. Okay, those parentheses are important. You do not drop the parentheses here. Never drop the parentheses here. Okay, so this is negative 2 times negative 2. All I do is take the inside and multiply it by itself. That's a positive 4. Again, you don't need to write the little plus, but I'm going to do it for a few of these. All right, f of negative 3 squared. Oh, f of negative 3 is negative 3 quantity squared. Remember, quantity means the parentheses. So that means do negative 3 times negative 3, and that will give you a positive 9. Why don't you try doing f of negative 4, f of negative 5, as well as f of negative 6. Okay, so now we're on the back page, and we're going to graph f of x. I just want to remind you that f of x is x squared. So I'm going to plot all the values that I can onto this graph. There are going to be a lot of values that you will not be able to plug in, so don't worry about like going off the graph or anything. You're just going to plug in enough to what you see. All right, so we saw that f of 0 was 0. I'm just plotting the ordered pair, 0, 0. F of 1 is 1. Notice you do not see the 1 here, okay? Because we're labeling every other one so that the graph doesn't look super cluttered. But know that halfway between 2 is 1. So this is going to be 3, that's going to be 5, and that's going to be 7. Okay, same thing here. This is 1, so this is 2, 3, 4, 5. All right. The scale for x is 1 because this tick mark here represents 1, even though we're only showing, the even numbers. Okay. The y scale is also 1 because each tick mark is worth 1. Okay, so don't let that fool you. All right, so we did that. That's 1, 1. 2, 4. I know we graphed that. 3, 9. 4, 16. All right, so I can't graph f of 5 because that's going to be much higher than 16. Remember, you're the one who's supposed to like figure that out. But we also graph some of the negatives. So we got negative 1. We have, negative 1, 1. We have negative 2, 4. We have negative 3, 9. Okay, and then I asked you to find f of negative 4, f of negative 5, and f of negative 6. You might be able to, I think you're going to be able to plot f of negative 4, but do you see a pattern? Okay, what I want you to do is copy this to the best of your ability, and then because it can keep going, we're going to put an arrow there. Okay, Now, I want you to finish plotting. I can guarantee you that f of negative 4 is going to be 16, so I'm just going to go ahead and finish this graph. Whee! Oops. It didn't quite go through the point, but, you know, I'll try again. You don't have to be super perfect, but the idea is there. And again, when you find f of negative 5 and f of negative 6, you're going to see that it's going to keep going. So we're going to put arrows there. Okay, so this is what f of x equals x squared looks like. We'll spend more time on linear and exponential functions in this class, but it's really important to know what x squared looks like as well. You'll be focusing on x squared a lot more in the next math course. So now we have this question: what is the domain and range of f of x? Write your answer in inequality notation. Okay, so I'm going to use highlighters here. If you don't have highlighters, that's totally fine. Use what you have. And I'm just going to, all right, I'm going to say that domain is going to be the pink and the orange is going to be the range. All right, so on this, I'm going to focus on the fact that I have arrows because we're going to read from left to right. Okay, this arrow, let's see, let me change some colors here. I need a purple-ish color and I also need an orangish color. Okay, purple. This arrow is pointing left. Okay, it is also pointing up. Okay, this one is pointing up, but it's also pointing right. So it has two directions. For a domain, we focus on left and right. Okay, so what does that mean? That means it's pointing to the left, which means it's coming from negative infinity, and it's going to cover all of these x values, all of them. And since I have an arrow pointing to the right, I'm also pointing here. So this is the entire number line. Okay, I just highlighted the entire x value. And by the way, this is going to positive infinity when you're pointing to the right. So in inequality notation, the domain of f of x is from negative infinity less than x, which is less than positive infinity. You never use this inequality. Never, okay? Never use that whenever you're touching or you're talking about infinity, because you can never reach infinity. You can never touch it, if you will, right? I can hit an x value of 4, which is fine if I stopped it here. But when you're going to infinities, you can never reach it, okay? It's a concept that says the numbers get super large in those directions. All right, so let's focus on the range now. So now I'm going to be focusing on the up and down. So when we read the range, we always start from the bottom and work our way to the top. So what I just highlighted is exactly what our range is. The lowest y value is 0. And then I go all the way up. All right. And then I'm going to make my arrow go up because these arrows are facing up as well. Okay. So here, if our arrows were pointing down, I'm coming from negative infinity, but I'm going to move up. So I'm going to start down here and up. I hit 0 first. So the range of f of x is from 0, and because there is a point that exists there, I'm going to say less than or equal to y, and then I'm going to read from here all the way up, and since I have an arrow, I'm actually going to positive infinity. Okay, so remember, never less than or equal to, just less than positive infinity. And that's the domain and range of f of x. All right, let's quickly work on g of x. G of x was the square root of x, by the way. So we had the coordinate point 0, 0. So we're going to put that there. We had the coordinate point 1, 1. Okay, and we had 4, 2. Then we had 9, 3. And then we had 16, 4. Right? And as you continue to work on your table, you will realize that it will keep going forever and ever. So we're going to put an arrow there. This is what the square root function looks like. In particular, the square root of x. So it makes this shape. All right, again, it says, what is the domain and range of g of x? Write your answer in inequality notation. So I use purple for domain, so that's a thick marker. Okay, domain of g of x this time. Okay, I'm going to read from left to right. So as I read from left to right, my graph doesn't exist here, but oh, this is the first place it exists, at x equals 0. Okay, so I'm going to put my closed circle here because I actually have a point at 0, 0. X can be, like x equals 0 can be plugged into this function. And all of these all of these x values are covered. Okay, so let me just double highlight that. All of these are covered, and you see that there's an arrow pointing which way? It's pointing to the right. All right, because it's pointing to the right, I'm going to positive infinity this way. So I'm going to write my inequality notation. I'm going to start at x equals 0. And since that can be equal to it, less than or equal to x. And then since I'm going all the way to positive infinity, less than positive infinity. Now let's work on the range. Again, we go from bottom to top. So my graph doesn't exist down here, but the first y value it exists is right here, which is at y equals 0. And then it goes all the way up y because this arrow is also facing up. Okay, so each arrow has 2 directions for now. So the range of g of x is 0 less than or equal to y, which is less than positive infinity, because that's where we're going. And I know I didn't highlight it, but let me go ahead and go back and do that. So from 0 to positive infinity. And that's how we find the domain and range of g of x. All right, so just to remind you, on the first page, I will know that your notes are complete when you finish this table, as well as this table, and these evaluations here. Okay, you should have everything else, everything that I have, you should have, and so your notes will be complete when the first page is completely done.